Hello everyone, my name is João and I hope you're having a great quantum game jam and creating a lot of fun games. Today I'm here to talk a little bit about the project that I developed, also a quantum game, but an actual physical board game. It's called Hop, the Quantum Game. I'm a researcher at the University of Geneva. I'm finishing my PhD right now in theoretical physics. I do transport in one-dimensional materials, so I really work with quantum systems. And I created Hop, which is a relatively fast strategy board game to be able to introduce people, in particular my family and friends, to concepts in quantum physics, which usually are very hard to get. So I try to transmit them through gameplay. So first I want to talk a little bit about the game. What is it? So in Hop, you play as physicists on a mission. You happen to be actually not so good physicists. You just broke a very expensive machine. You might be young, inexperienced perhaps, and you just broke it and you gotta find out who's the responsible one before the professor arrives. And you don't want to be the responsible person, so you really try to short circuit your friends towards victory. And in the game, it goes like this. You first start to set up a lattice or a grid of cards. They represent your machine that somebody is going to short circuit. Then you're going to be placing your electrodes on this machine. There are cards like this. Oh, let's put it the other way around. Where each player is going to position their electrode on the grid, and all the electrons are going to flow from this electrode to the opponents to create a short circuit and win the game. The first one that gets short circuited loses, the rest are safe for now. In the game, you learn about quantum mechanics through the game mechanics itself. There are movements that you do to be able to move your electrons that are quantum based, such as, for example, quantum tunneling or hopping or quantum Newton's cradle. These are things that you can do to move your electrons around and achieve your goal. Also, in the game, you learn about the concept of energy conservation through the Hamiltonian. Every time that you need to expand energy, you need to spend an actual physical energy token like this. And every time you lower the energy, you get it back to you. So there is this gameplay that depending on the Hamiltonian that you play, different energy exchanges need to take place. In the game, you also learn other physical effects that come up as special effects that you can use. But today, my focus is really on talking a little bit about the game process, how I created the game, how my knowledge and experience can perhaps help you develop your online version or your virtual quantum game. I know it's not the same, but for sure there are challenges that maybe we share together and I've overcome them or not. And we can definitely talk about that. If you want to learn more about the game, you can check the hopquantumgame.com. I have all the info there. I'm also showing some images related to the website, so you get familiar with it. Then, okay, so let me tell a little bit about the story of the game. I started developing the game in the beginning of my PhD in 2019, early 2019. And it kind of came as an idea after a game session in a board game cafe. And I really realized, okay, I could actually try to do a board game, and it's much needed. Unfortunately, there are a lot of fun experiments that one can do to try to bring young physicists to the field, but there is almost none, as you know very well, to try to bring physicists towards theoretical physics, in particular theoretical quantum physics. At the time, now there is a lot of new games that has come out, but at the time it was not definitely not so many. So then I decided, okay, I could do something which is related to my physics. This way I can explain what I do, my research to my friends and family. And in game design, usually there is two directions that you can do your game. You can either start by a really cool game mechanics that you found out and you want to explore, or you can start by having a concept that you want to explore through games. In this case, it was the second. I wanted to really just showcase what I do. And what I do are lattices. Okay, so I work with lattices, which are simply atoms which are arranged in a grid. I particularly work in a line, I work with one-dimensional materials, but more generally, whenever you have a metal, for example, atoms are very nicely arranged in a grid. And I really wanted to show this. So the first idea of the game that I really wanted to show was the idea that there are different sides and perhaps electrons can move from side to side. So this was the first game element that I thought of. It represents a site in your material, site in your material, and it can be populated by two electrons which have a spin up or a spin down. This way I could teach about spin, and I could also teach about energy, because in real life usually the two spins, they are separated in energy. So every time you do a movement, you're gonna have to think about how can I consider the energy. So this was a concept that I really wanted to explain from the beginning. So I've kept it throughout my game development. Even in the final version of the game, you still use these cards, you still hop around, and every time you do so, you need to think about in terms of energy, what you're doing, and this way you learn how the Hamiltonian works in a physical system. And very early on, perhaps one of the big choices that one has to do when you're doing game design is if you are doing a collaborative game or a competitive game. I tried a cooperative game, but I really couldn't make it work. In general, cooperative games are hard to do. People have to work together, and there was a lot of problems in terms of physics that I could not overcome. So I could not make a game that was consistent enough that and it was fun enough that people really wanted to play it. So early on, I kind of dropped this idea of doing a cooperative game and shifted towards a competitive game. Honestly, I find it a bit easier and I could actually do a better work on it. But if you are designing a cooperative game, go for it. It's very hard to do so, but if you succeed, I really do enjoy cooperative games, so also let me know. Very important in this choice where to do the cooperative game was that I was basically torn apart between doing a game that was a good board game and a game that was actually teaching something in physics. So it's very important when you're developing a game, you need to decide certainly how close to physics can you be. Because in my constraint, for example, doing entanglement is very hard. So I had to find a different way of showing entanglement. You are doing an online game, it's a bit easier to do entanglement, but in general, physical systems are not games. So one is to find a good balance between these two. What can I tell you about this? I mean, you're gonna have to choose your own balance, but I really invite you to strive to be as close as possible to physics. Because people that are not physicists, sometimes they are misled by metaphors, examples that pick some of the physics but not other parts. So in general, I would say that the most you can say in physics, the better, but it can be really hard in terms of game design, and there will always have to be some sacrifices that you need to be willing to make, because at the end, the game also needs to be fun. So try to keep as much as physics as possible, but don't be afraid to give up a little bit of physics so you have a much better game. For example, a good example of that I had to do this was the fact that if you are doing a physical board game, electrons are indistinguishable, especially if you are doing a competitive game. But these are very, very distinguishable. They have different colors. And how do you put this in the game? You can't put electrons that are indistinguishable, because that's not physically, it makes no sense. So I kind of accepted at some point that they need to be physically distinguishable. And for the purposes of winning the game, you need to put an electron from, for example, a purple electron in yellow source or yellow electrode. But every time you do a movement, actually the color doesn't matter. So per example, there are movements where you'll be able to go together with your opponent to some other side. So I had to find this balance, and this was a really tough decision, but in the end it just made the game definitely much better for people to play. And then other aspects of game design that you might find in your game is that perhaps you have a good idea and it works really well, but probably it either is going to be perhaps boring or very interesting, but it might take too long or too little. You need to find a balance for the game. And here I invite you to think about two things that are very important. One is, who's your target audience? Perhaps you're playing with adults. We tend to have a bit more time and a bit more patience to play longer games, but perhaps you're targeting children and their attention span is nearly not as high. So you need to find a good balance between these two elements. Understand your target audience, and in this way be able to really fine-tune your game. For example, I developed the game first as a random game where the movements that you took were chosen from a pile of cards. This made the game very random, and I had a lot of difficulties making it fast because cards can come up randomly. So the game was actually sometimes taking 2 hours to play, sometimes it was taking 5 minutes. It was actually very, very wildly, but in general it was too long. One thing that really changed at some point was that we introduced, actually together with my co-game designer, we introduced a new game mechanics where there was no randomness. So the cards were there, everybody was playing the cards that were there. And in this way, it managed to make the game much easier to fine-tune. You just had to go element by element, see which elements were slowing down the game, and you could remove them and substitute by others. So indeed, there are some techniques that you can use. This is, for example, one of them if you are in a problem of trying to cut down your game, which can be definitely a big problem. And as I was also referring to children and adults, they have different capacity of understanding concepts. So, for example, I could have done a game for physicists where you have to be playing with entanglement full on, and you have to do the math and try to understand how to do the entanglement. But this was not my goal. I was trying to reach children, teenagers, and in general the public audience. So I, for example, don't have a lot of entanglement in the game. I try to reduce it and focus more on other quantum concepts. The players in this case, they play a bit like on a pointer state, so they play on up or down, and they do not play with so much with entanglement. But I managed to find a way to introduce it in the game later a bit as an effect card. So it's kind of something you can play, but it's something only if you play if you wish. You don't have to. And this is also another advice that I might give you, perhaps in your game. You might have elements that are too complicated for your target audience. It doesn't mean that you completely have to scratch them. Perhaps you can divide your game into parts. My game is divided into 3 parts: Bachelor, Master, and PhD. All of them introduce slowly one concept of the game. For example, the first introduces movement, the other introduces energy, and the third level introduces effects that here are a bit more complex. They are usually not for young children. So I managed to divide the game, and actually by dividing it, now the game can be played both by tenured professors and also high school students. So it might even help you, give you a bit longevity, might help you make your game last longer. But finally, I'm a bit out of time. I want to give you a last advice. At some point, we cannot do everything. Maybe you're doing the quantum jam now, you're coding a little bit, but maybe you need a designer, or maybe you need somebody to write a rule book for you. So you need to be able to bring people on board, and for that you need money. And game jams are great for getting money, perhaps. Another financial tip that people don't know so much are foundations. Science foundations, private foundations that are oriented towards sharing Science with the Citizens. I really advise you to check it out. Maybe you have one in your country, maybe one in your continent. Check it out. They are usually good sources of money and that you can use to further develop your game. I wish you the best of luck with your Quantum Jam and hope to answer all your questions. I might not be there when this video shows, but I will be certainly after available to answer all the questions on Discord. Please send me a message and see you. Thank you very much.